Okay, so we have here 7 minus 5x is equal to 3x minus 9. And we want to try to get our variables together on one side and the numbers on the other. So how could we do that? Okay, that's a great idea. If I subtract this 7, that's going to get the numbers all to the right-hand side, or excuse me, right-hand side for you guys. So negative 7 from 7 cancels it out. Negative 9 minus 7 be negative 16, right? If you subtract a negative, or subtract from a negative, makes it more negative. And then what's on the left-hand side? Negative 5x. Be very careful not to drop that minus sign there. That's a very common mistake, is dropping that minus sign that's in front of that 5. It's a negative 5. Now we need to get the x's over here with the negative 5x. So how do I move this 3x? I'm going to subtract 3x. Be negative 16 on that side. And then negative 5 minus 3. Right there. Negative 9 minus 7. And then that would be negative 8x on the left-hand side. And then we got a one-step problem to do. So how would we solve this? Divide by negative 8. Yeah, positive 2. You could go back to the original problem, plug it back in, see if it works. And we'd have 7 minus 10, negative 3. And here we have 6 minus 9 is also negative 3. So it does check in the original problem. Not very difficult, just maybe one extra step from what we were doing last week. Maybe not even that much, maybe the same number of steps. Look at example B. 6x minus 11 is equal to 2x plus 9. Very similar problem. Anna? If we add 11 to both sides, that's going to cancel out on that side. Give us a 6x equals 2x plus 20. That's good. And then what? Minus the 2x. Yeah, that's right, guys. You are doing good. That gets the like terms together. 4x is equal to 20. Yeah, divide by the 4, the last step, and x is 5. You guys are pretty good at this. Not too bad. Okay. Are you writing anything down? Okay. I'm not moving very fast. All right, let's look at this one. 24 minus 3m is equal to 5m. So maybe a little shorter problem. Maybe not quite as much stuff to do here. But we got to think about what we need to do and why we need to do that. Okay, so that'd get the like terms over there on the right-hand side now. Okay, so 5m plus 3m would be positive 8m. And we have what's left on the left-hand side of this problem? 24, still there. Last step. Divide by 8. M is equal to positive or negative? Positive 3. Good job. And you could plug that back in and check. So 15 on this side, 24 minus 9 is 15. It does check. It's to be the right answer. That one. All right. Well, let's do this in 3 parentheses 2x plus 4 equals 8x minus 7. Okay, yeah, I heard somebody say distributive property. Yeah, that's what's going on here. 3 times 2x and 3 times 4. which would be 6x plus 12. And now what's one possible way to work this one? Okay, you could subtract 6x. You could add 7 to both sides if you wanted to. You could also minus 12, whichever way you want to do that. I'm going to add 7. That way I just get rid of the minus part. But subtracting 12 would also be correct here. There's 8x by itself now. And we have 6x plus 19. And then what? $19 equals positive 2x or negative 2x? Positive 2x. Good job. Divide by the 2. And leave it as that improper fraction. Reduce it if possible, but leave it improper. Okay. All right. A little bit longer. I mean, that's kind of like when we're getting to harder material. It's a little longer question. A little bit, more to explain about what's going on there. So example E here. 9x minus a 5, 1/4, parentheses, 16x plus 60. Ooh. That looks rough because it's got a fraction in it. But, so what's going on the right-hand side? It's distributive property. And for these, there's a lot more happening on the left-hand side than there were on the ones we were doing the other day where we did the reciprocal thing. So that may not be the best thing to do here. It would work, but here's a good little check here. Does 4 go into 16? Does 4 go into 60? Yeah, it does evenly. So doing the distributive property is not going to create us more fractions on this one. It's going to actually make those numbers go smaller. So I'm going to distribute the 1/4 to both of those. 1/4 of 16 would be 4. 1/4 of 60 is 15. And then we have tons of options in order to get x by itself. We have a minus 5 right here, so we could get rid of that by doing what? Adding 5 to both sides, and that'd get it over here with the 15. And that would get us a little closer to having x by itself. So that's what I'm going to do, is add 5 to both sides. Be 4x plus 20. And then the next move, since I added 5 there, the next move would be to do what? Subtract the 4x. I don't want to subtract the 9 because that gets everything on one side. I need to get x's on one side, numbers on the other. So be careful with that. Be 9x minus 4x is 5x is equal to 20. And then last step, divide by 5. X equals positive 4. If you did it a different way, you could still get the same exact answer. So if you, up here at the red line here, if you had subtracted 4x first and then added 5, that's still legal. How did you do it, Jalen? The 4 and multiplied 4 times 9 and 4 times 5 and got 36 minus 20, and then moved the 16 and the 60. Yeah, Jalen said he did the reciprocal thing here and multiplied this side by 4, which works, and he got the exact same answer we did. So there's nothing, if anybody ever tells you that's the only way to solve an equation, they just don't know another way, because there always more than one way to do these equations. It can get confusing if you try to look at too many different ways, but if you'll just kind of, you look at it and say, okay, I'm just getting the x's together, then I'm getting the numbers together on the other side. If you'll take that approach to it and do it with the right operations, then you'll be okay. All right, let's look at another one. Let's say we had 4x is equal to 4 parentheses 5 plus x. Okay, what would be our first step here? That? Distributive property. I like it. That's what I would do. Be 20 plus 4x. We got 4x there. And then what? Anna? Okay, so if we're going to move this 4x over to the other side, this cancels. But what happens over here on the left-hand side? It cancels as well. So that's 0. Does 0 equal 20? No, this is a false statement. 0 does not equal 20. That's exactly right. No solution on that. No solution, because 0 does not equal 20. That's why that's the case. No, you don't have to write false. I just put that in there to say, hey, this is a false statement, and that's why it's no solution. You don't have to write false. Just think that. That's kind of what. Okay. 3 parentheses 2x minus 7 equals 6 parentheses x minus 7 over 2. So a little fraction in there. So what should we do first? Yeah, I would distribute the 3, and then at the same time I'm going to distribute the 6 on the other side. I think that's a fair thing to do. So that's going to be 6x minus 21. And then I distribute the 6, I get 6x minus 21. And if I try to get the x's together, what would I do? I would subtract 6x, right? And end up with negative 21 is equal to negative 21. Does negative 21 equal negative 21? Actually, infinite many goes with systems of equations. This would be, I would call this what's called the identity, or all real numbers. Identity is one word that means that they are exactly the same on both sides. And then all real numbers just means it doesn't matter what number you pick, plug in for x, it's going to work in this equation. You could pick the square root of 75 and it would work in this. Any number, any real number. Okay? So, if you see the variables cancel out, you look at what's left. If it's true, identity, all real numbers. If it's false, like this one was, then we have a no solution situation. Okay? All right. Let's do one word problem that I didn't have written out for you previous to this, and then example H, I guess. Let's do another special equation before we do the word problem. I don't want to leave this one out because I've seen in the past that it tends to cause people to miss problems. All right, so 5n plus 6 is equal to 6 parentheses n plus 1. Okay? Excuse me. What's the first step? Distributive property. We're going to see that a lot in this section. Be 6n plus 6. Then what would you do next? Okay. So which one are we subtracting? Say it again. Just 6? Yeah, I could do that. That cancels over there. I get 5n is equal to 6n plus 0, technically. Now, are all my variables together yet? No, so I need to get those together. So which one do we want to move? Yeah, I'm going to subtract the 5n. I think that's the best method there. Because 6 minus 5 is easier than 5 minus 6, right? That'd be 1n. What's on the left-hand side here now? 0. There's nothing there. It's nothing in math is 0. Now, what's next? Divide by 1. What's 0 divided by 1? 0. So, you mean like right here, knowing that these cancel each other out, that it's going to be n equals 0? Yeah, that's true. Absolutely, that will always be the case. If the numbers cancel out, then your variable is going to have to be equal to 0. That's true. That's true. Okay? Anna.
If you subtracted the 5 instead of subtracting the 6, would that make the equation shorter?
No, it's the same number of steps then. That's because you'd end up subtracting the 6 the next step, and then so it's exactly the same number of steps. Emily?
I subtracted 5 on both sides and got.
If you subtracted 5n, right, like at this step, is that where you're saying you did it? Okay, that's absolutely fine. You should end up with 6 is equal to 1n plus 6, right? The next step would be subtract 6, which would get us to the exact same problem. 1n is equal to 0. Maybe a mis-subtraction or something there that could cause a problem there. But it doesn't matter what you do next. Like Molly said, at this point, she knew it was n equals 0 because, you got the same number over here and the rest of it's variables. That's true. It is going to be that. If you had moved the 5 in, you end up, still at the same point at one, as we got here. So there's multiple ways of getting these answers. You don't have to go in the same order as everybody else does. If you're following, all the rules of math the right way. Okay, so let's look at a quick little word problem application of solving some equations. And you use equations every day, like in regular life. You may not write them out like an equation and work it out that way. But like if you're in the grocery store trying to decide which one's the better buy, technically you're doing an equation in your head, or you're doing a comparison in your head, and that's what equations are. Are these two products equal? That sort of thing. So it is a logical, we're not necessarily trying to teach you math here. We're trying to teach you how to think logically. So I want to try to, apply this and show you can set up an equation and do stuff. It's not something I do every day in life, but it is something that can help you. All right, so let's look at this. A car dealership. Sold 78 new cars and 67 used cars this year. The number of new cars sold has been increasing. What's increasing mean? Going up by 6 cars per year. The number of used cars sold has been, handwriting got bad there, decreasing by 4 cars each year. When will the number of new cars sold be twice the number of used cars sold? That's our question. When will the number of new cars sold be 2 times the number of used cars? Huh? It is an intimidating problem. It really is. It's a word problem. So many words, but there are only certain important ones. Right? Yeah, increase by. So I'm going to highlight some of those words. We're going to use this poster over here I got this summer or right before the beginning of school. So it says it's Math Unravel is the name of it, and it's a good way to approach word problems, and it'll help you if you'll think this way. The first thing it says is underline the question. So I'm going to underline the question. When will the number of new cars sold be twice the number of used cars sold? So I'm underlining. That's what I want to know at the end. If I know that question first, that helps me. Okay, it gives me an idea of what I'm going for. So when I get done, whatever number I get should be in what unit? What's the question asking? When? Years. It should be in years, like how many years from now? Okay. Now, second line says, now predict what you think you need to do to solve the problem. Well, kind of think about it in context of where we're at. What do you think we're going to set up? What did we just finish doing a bunch of examples of? Equations. I think that might be the best way to break this down as an equation. Okay. Then it says read the word problem. Okay, so let's go back and read it. We wrote it down just a second ago. Let's read the problem. It says a dealership sold 78 new cars. And then I like to do the third line and the fourth line. Are there any important words circled? Especially clue words. And this is where we're going to, as we're reading it, circle those words. Okay? So they sold 78 new cars. That's probably pretty important. And 67 used cars. That's important. The number of new cars sold has been increasing. Y'all said that was important already, right? Y'all said that's increasing by 6. That's important. And then it says the number of used cars sold has been decreasing by 4. That's important. Okay, those are the important parts of this problem. So we've condensed this down to the important part being 78 new cars, 67 used cars, increasing by 6. Decreasing by 4. So we've got it down to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 words that are important out of that are going to be helpful in setting up our equation. Okay? And then you apply the steps you chose to solve the problem. The steps we chose are set up an equation. So this is where we're going to set up an equation. All right? So when you're looking at this and you're saying, okay, they're wanting to know when will the new cars be equal to twice as many used cars. Right? So that means we got 2 sides of the equation. We got a new side and a used side. Kind of like a car lot's got a new side, and then they got a set of used cars over here parked on the other side of the parking lot. So they're separated. So our equation is going to have some stuff with new cars over here, stuff with used cars on the right. Okay? And it says they had 78 new cars that they sold this year, and it's been increasing by 6 every year. Okay? So if they had 78 this year, to get next year's, they'd say plus 6, right? And then to get 2 years from now, they'd say plus 12. And to get 3 years from now, they'd say plus 18. So they're saying 6 times every how many years it's been. Right? And then we look at the used cars and we say, okay, what's happening to the used cars? Well, they sold 67 to start with, but then what's happening? They're decreasing by how much? 4 every year. So that would be, in our equation, 4y, and we're doing what with it? Subtracting, because we're decreasing, right? Now, here's where we got to apply the rest of it. It says, when will, this is the question says, when will it be twice as many new ones as used ones? So what's getting doubled? The used ones. Twice as many new ones as used ones. So the used ones is the smaller amount. So it needs to double in order to get to this number. Oh, this will be. Now we have an equation. And this is where we apply those steps of solving it. We know how to solve that equation, right? How do we solve that equation? Distributive property would be a good way to start. 2 times 67 be what, a 134? And then 78 plus 6y. Now what? Okay, we could subtract 78. 6y is equal to 56 minus 8y. Add the 8y, good. Be 14y. Divide by 14. How many times does 14 go into 56? Well, 7 goes into 56 8 times, and into that 2 times, so that'd be 4, right? 4 years. In 4 years, we will sell twice as many new cars as we do used cars, if everything stays the same with our car dealership. And, evidently they've been tracking this for a little while, so they know that that's what's happening, okay? Word problems are doable. You just got to start trying to break them down a little at a time. And that little poster over there can be helpful, and that's going to be up all year, so you'll be able to look at it and stuff to help you with word problems. But if you'll take it piece by piece, a lot of times that can make the solving of word problems easier, because they are intimidating, because they're big, long things about reading, and that was my worst subject in math, or in math was reading. My worst subject in school was English and reading, and public speaking was second. But math was always easy, but the word problems were tough because you had to read, and I struggled with those, so I'd figure out ways to get them right, because I couldn't stand to not get them right. All right, so this is what I want you working on for the rest of the time. It's on page 157. Let's do number 3 through 26. Let's do all of those. And then let's pick up 31 through 45. Let's just do the odd ones in that little set.